What is the largest order of an element in the group of permutations of 5 objects? So my instinct here is that the answer is 5. But, and that is one of the answers given. So I'm extremely rusty on my specifics of group theory, but of course I can create an element in the group of permutations which has order 5. Just think of the ordering of 5 objects and shift them all to the left by 1, with the first one coming back to the end. You do that 5 times, you get back to the original setup. Are there any? The largest order of an element. No, so I can think of something that's got a larger order already. If I think of the 5 objects as a group of 3 and a group of 2, then the permutation, which is cyclic here and cyclic here, so it takes this element and moves it to the back, this element moves here, and this element moves there, and at the same time it swaps these two, that will have an order of 6. Because in order for these 3 to get back to the original arrangement, you have to do that 3 times. But then these ones, after flopping 3 times, will not be back in the original arrangement. And so you'd have to do it 3 more times. So I can definitely get something with an order of 6. But I'm sure there's probably some kind of theorem about divisibility of groups and something like that. So the answer is definitely not 120, because if the number of permutations of a group of 5 objects, that group itself has a size of 120. And it's not a cyclic group, so it definitely can't be that. I'm not sure exactly what kind of, there must be some theoretical result about groups in general, or maybe even specifically about these permutation groups, which would allow you to solve this. But I mean, 120, if I write out the factorization of this is 60 times 2, which is 30 times 2 squared, which is 15 times 2 cubed, which is 3, so that's 2 cubed times 3 times 5. Is there something we can look at with this prime factorization to find the largest possible order? I mean, that the factorization alone can't be enough, because there's a cyclic group that has this order, and then in that case the answer would be 120. something like this might help us find the smallest order, but I'm not sure. I mean, the answer is obviously not 5 or 120 because I've come up with counterexamples. So yeah, I created, the permutation that I described here with the cyclic over the first group and then flopping those ones. That has order 6, but I think you might be able to do better than that. Like what if we took these 3, cyclically permuted them, flopped those ones, and then also interchange these 2 and then took this one and put it at the back or something like that. I'm not sure. I mean, I'm sure there's a good way of doing this question which isn't about just trying to construct the object that has the largest order. I mean, I'm going to say 6, but I'm not confident. I'm not confident in this very much. It very well could be something higher. So that's option B. But yeah, very, very little confidence in my answer here. I will, once I check the solution to this, I'll be sure to include what the correct answer is. But I would even have to do a little bit of research on my own to figure out how to arrive at that answer. But I don't really have any other ideas of how to approach this right now without remembering my results about group theory, other than just struggling for a long time to create an element that has a higher order than 6. So I'll call it here. Thanks for watching.